Jerry mentioned, I'm Jack Wright, so I'm a sales engineer with Boland. I'm going to be kind of your moderator today. So right here, the focus again is we're going to be looking at the design, installation, and actual application, and then services that have been associated with it. How Tommy, who's our building owner here, feels with the systems after they've been running for, I think the oldest one's about 2 years.
Yep.
Okay, perfect. We're going to have some questions we go through. Each of the panels are going to go through that. It's designed to, again, go through this whole process from the beginning towards the end. If you do have any questions, the next slide's going to have a QR code. You can scan it with your phone. That will send a question to us. And then if we have time at the end, we'll kind of review those ones and go through it. If there's any questions we don't get to by the end of it, we're all going to be here after the meeting. So feel free to just come up to us and ask that question then. So before we get started, we're going to do a quick overview of hybrid VRF. So hybrid VRF is going to be a hybridization of essentially your typical two-pipe fan coil system and then traditional VRF. It takes kind of the pluses and minuses of each system and combines it together. So essentially we use a traditional condensing unit, whether that's water-cooled or air-cooled for VRF. It's then paired with refrigerant lines to a branch selector box. But the big change is then downstream of the branch selector box, we're going to have water piping. So you're effectively removing the refrigerant from the space. So what this gives you is you get the typical high efficiencies, you get the heat recovery, you have your different zone controls as you would get with the normal VRF system. But like I said, you've removed then your refrigerant from the space. So ASHRAE 15 calculations become a little bit easier. Install and maintenance, it's a little bit easier. Again, you're dealing with water piping instead of refrigerant piping. So without a further we're going to have everyone introduce themselves. So we pick people strategically through kind of the whole process of the design. So start off with the side. We've got Brad over here.
I'm Brad McNiff with GHT Limited. I'm a senior principal with a mechanical engineering degree. I've been with GHT for 17 years, and I'm currently managing the mechanical design studio in our building system studio, which focuses on new construction, capital improvements, renovations, odd markets like healthcare and life sciences, and we do a heavy amount of commercial interiors office as well.
Next, we got Mike Silverstein.
Mike Silverstein with Mitsubishi Electric Trane HVAC US LLC. I know it's quite the mouthful. We call it METIS for short. And the name came about because about 8 years ago, Trane and Mitsubishi came together in a joint venture. So this is a great way of blending the HVAC know-how of Trane and the VRF technology of Mitsubishi. And I'm the regional sales manager here for commercial applications here in the Washington, D.C. area. So I really help support Boland and all their efforts when it comes to the Mitsubishi technologies, whether that's VRF, mini splits, air-to-water heat pumps, and the hybrid VRF.
We have Tommy Russo.
I'm Tommy. I'm Senior Vice President of Technology and Engineering at ASHRAE. I oversee our portfolio of 40 plus buildings, our construction, all of our engineers, all of our technology. We were one of the first, if not the first, to do the hybrid system, and we did it for a specific reason. I thought it was easier to work with moving forward, save energy, easy to control, and the whole package.
Great. And then we got Mike Shirley.
Hey, Mike Shirley with KMN Mechanical. We were the first ones installed in this area, in this building. Been a tech for 40 years, senior tech, been at KMN for 35 years.
So again, thank you everyone for coming. Thank you to our panelists coming here. Again, we should have a pretty good wide representation from, the actual manufacturer's rep, the designer, to the owner, to the installer. So without that, we'll get started. So what are some reasons you would choose to design a building with hybrid VRF?
So hybrid VRF, much like traditional VRF, is a great solution when things like personal comfort and energy efficiency are your primary drivers, right? With the ability to have multiple zones, and each zone it has the ability to have simultaneous cooling and heating. Every zone, every occupant can choose the comfort that they want. And then mixing that with the VRF, the inverter compressor technology, you're really only using the amount of energy you need to meet that specific demand in real time. So it's very energy efficient. And what the hybrid does is it allows you to mitigate where you're using your refrigerant so that you only have water running into your occupied spaces. So it's a really good fit for personalized comfort, energy efficiency, and mitigating where your refrigerant is being used.
I'll add on to what Mike said. So, as a design engineer, the very first thing I think about when installing VRF systems is our ASHRAE 15 refrigerant concentration limits. Those are some of the biggest hurdles to overcome when using a VRF system. So, when we heard about the hybrid system, the most obvious advantage was removing refrigerant from your occupied zones, a total reduction in refrigerant volume for the entire system. So, for example, the mechanical codes in ASHRAE 15 limit where you can have refrigerant piping. Specifically, it's excluded in corridors, lobbies, very limited use in institutional occupancies. But with the hybrid VRF system, that opens the doors to using some of those spaces. And the other consideration specifically for this building, a little bit of background on the Homer building. So the original mechanical system had a constant volume interior air handling system, self-contained units with perimeter console heat pumps under the windows. So as part of the repositioning here, modernizing the building, we removed the console heat pumps under the window in favor of the VRF system. Still very, very efficient because it's still heat pump technology. We're removing a source of sound and the physical presence of mechanical unit in the occupied space. So that was really kind of a win-win for the building renovation.
And then you guys both mentioned ASHRAE 15, so refrigerant calcs. Those you don't know, we went through a recent phase out. So we've switched from R410A with high pressure systems to either 32 or 454B. Those both are now A2L refrigerants. So you guys kind of want to share, I guess, some of the impacts that's had on the design. So going from, our legacy refrigerant to the new refrigerant and why that may be a bigger impact on your ASHRAE 15 calcs moving forward.
Mike or Beth. Sure. So I'm sure we can both speak to this. So, as you may know, that the new lower GWP refrigerants are classified as A2L, with that L designation meaning slightly flammable, which puts it into a different safety classification in the code. So when that came out, we had a lot of people in the industry panicking, like flammable. What are you talking about? I'm putting these flammable gas all throughout my building. But I think it's very important to know that it's slight. You can hold a flame up to this gas and it will not ignite. It's common in buildings to run gas pipe all throughout, natural gas pipe all throughout your buildings, and there's very little restriction on that. But there's a lot of code written around this slightly flammable refrigerant piping. So it was a little bit of a misnomer. It's just I view it as a learning curve for us and just using something new. A2L refrigerants have been used in Europe for decades probably, so it's not new to the industry. It's just new here. Anything you want to add?
Yeah, the only thing I'll add to that is that there was a shift in the ASHRAE 15 safety standard from dealing with a material or refrigerant that was heavier than air, and we were concerned of someone could asphyxiate, right? It could be harmful if someone didn't have enough air in their space. And the shift was from that to, all right, I have this very slightly flammable material, and what do we need to do to ensure that if there's a leak, can it disperse enough so that it no longer could cause a potential harm in terms of a fire or a flame? So a very different kind of approach that the safety standard is taking from the traditional view.
All that to say is kind of the calculations were originally you're allowed 26 pounds per 1,000 cubic feet, and now we're back down to about 4.5 pounds, depending on, if you're going with 32 or 454B. So again, very safe refrigerant, been used forever, but Brad's job, he still has to be in compliance with code, so he still needs to run all those calculations to make sure that we're below that threshold. So appreciate your insight there. So now on to Tommy. So Tommy, as our owner, kind of a two-part question. So what drove you to choose to install hybrid VRF? And in addition to that, hybrid VRF, you were probably the first system. Actually, you were the first system in our local area, but one of the first systems in the US. So it has been in Europe, but an early adopter in the US side. What kind of gave you the confidence to try a newer system and, feel this was the right move for your building here?
The first answer would be picking the right partner. The correct partner makes all the difference in the world. If you have somebody who doesn't know, doesn't believe in their product, or doesn't have confidence in their product, you can't use it. And I'm blessed that we manage, 40 couple of buildings in the district, and I've worked with all the manufacturers, but one, really stands behind their product, and that's Trane and Boland. And that made me confident. If they were confident enough to say, we're going to sell it to you, I'm confident enough to say to put it in. That's the first part. The second part is, in DC, we're limited by height. So square footage is what is really important. And truth be told, heat pumps aren't bad. They're just ugly to look at, take up floor space, and they make noise, right? So, but you get great comfort, and they don't take that much floor plate, right? Ductwork and VAVs and things lower our ceiling height. We're already limited in height constriction. So what can we do? How can we bring cooling to the individuals without taking up ceiling space or floor space? And the answer is VRF, right? So we've built 2 complete buildings with VRF. We've renovated this entire building with VRF. And once hybrid became available, to me, it was a no-brainer. I've lived through changes, moves, and everyone in this industry who's been in this industry for more than a year or two knows what happens. Contraction and expansion all the time of space. And when you go with the traditional VRF, it's very costly. You have to evacuate the entire system. You have to move the refrigerant lines. Installations are very expensive because you have to braze all the time with nitrogen in the systems. You have to make sure they're not using bandsaws. I mean, it's very, very tough to maintain that job site. So I looked at it and said, if it works, I'm going to do it for sure. Our first client, which is 2 years ago, is in the building. It's American Forestry. They got the proposal, and at the time, 2 years ago, the difference was around 5% of the cost of the installation. Now, 5% on a big job, maybe it's a big number, but it's not that big a number. They care about the environment and the earth as a whole. They are an industry that does pulp and paper. I was blessed. I got to pitch it to them, and they said, we want it. The ownership came back and said, well, like 5% is 5%. We're not going to do it. The client said, hey, no, we're doing it. And we put it in. That was the history. From that point forward, we edict that anything we're going to put in is going to be hybrid. Move, change, replace. It makes sense. Why would I want to put refrigerant lines in my ceiling? You know, I've never met someone that's partly pregnant, ever. So flammable is flammable. Pregnant is pregnant, right? It doesn't matter what it is. And the gas line, you know, we don't really put gas lines in client spaces because you can't put ovens or kitchens. They're more commercial spaces. So when you look at the whole picture, it's the whole picture. My biggest concern, I think I said originally, was I was worried about humidity. And, you know, with water, you're not going to the extreme low or the extreme high. You're staying somewhere in the middle. And I thought, well, humidity could be a problem. Well, our first build was American Paper. And their space is built out literally with cardboard on the ceilings and pulp wallpaper. So not wallpaper, just pulp put on the walls. 2 seasons cooling, 1 season heating so far. There's absolutely no humidity problem whatsoever. None. Happiest client out there. I mean, they allow me to walk anyone through their space all the time, working with the Trane guys. I mean, it's been the Boland guys. It has been absolutely phenomenal. They have, from the start to the finish, to pre-construction, to during construction and finishing, your confidence and the best product.
And just for reference for everyone, so Tom is talking about humidity, comfort in the space. So Homer building, very old historic building. Right now they have interior spaces are served by recently updated self-contained units. Brad mentioned they replaced all the perimeter console water source heat pumps with these VRF systems. But these systems are seeing pretty much raw outside air coming in through 2 massive makeup air units.
Sure.
So the application would be considered not a truly decoupled DOAS system, but something that's seeing a mixed air application. All right, here's a fun one. What are some specific design considerations everyone should be aware of when evaluating hybrid VRF? And we can bridge that to just evaluating VRF in general if you want. Let's start with Brad, and then we can kind of just walk down the line.
So I'll start with the point that Tommy brought up, and that's churn of tenant space. VRF is a more challenging system to plan for in a speculative environment. And it needs to be done very carefully. With traditional VRF, line lengths, refrigerant pipe size, the installation all needs to be very, very carefully managed. Oversaw by the design engineer, the contractor, the owner, the vendor. And so it's a little bit more sensitive in terms of the installation to get the system correct. The advantage of hybrid VRF in this instance is that there's less refrigerant piping. When you have a lot of churn in a tenant space, the system is much more flexible with regards to using hydronic piping downstream of the branch control box. So it's much easier to change out fan coil units, to move those locations, to move that hydronic piping. And I think we can talk a little bit about sort of the differences between how the refrigerant and hydronic piping in the installation. So that would be the biggest thing with respect to planning for an office environment. And I know we're going to talk about lessons learned in a little bit. Okay.
So Mike, I guess maybe touch on piping differences. Are there any real differences between designing a traditional VRF system versus a hybrid VRF system that you've seen, or what was the goal when Mitsubishi kind of came out with this product?
Yeah, I'd also like to add too, I think another important element of the design when we're thinking about laying these systems out is the branch circuit controller placement. I think that's a key element in the design. That is it in a location that is serviceable, right? If I need to access it, and is it in a location that, although they're quiet, there's still some sound emanating in it, is going to be an area that is not so sound sensitive. And then as far as the piping, one of the nice things as we switch from traditional VRF to the hybrid is downstream of that branch circuit controller is all just hydronics. So it's water piping, and that gives you much more flexibility of what materials you may want to choose, or how you want to make your connections, versus a traditional VRF that you need something compatible with your refrigerant and this high pressures. Now it's a hydronic system using water at a low pressure, and you've got flexibility of using copper or a multi-layer plastic type material also that can help you potentially either could be lower cost or just a different material. MLP piping is fairly popular in Europe, less so here in the US. So the price point is still somewhat high relative to copper, but I think we'll find as we see more and more of this MLP piping, it'll give installers and designers additional options of what they can do on some of that piping.
Great. I'm going to skip you, Tommy, for this one. Go to Mike. So Mike, when you're installing a VRF system, and you can share both hybrid and traditional, I mean, what are you telling your guys? What are you worried about? What's your main concerns that kind of go into actually installing whatever was designed on the paper?
I mean, if you're doing a refrigerant pipe, you have to make sure it's clean when you're brazing. Gotta have the nitrogen flowing. The difference is, I mean, the water piping, we've been using ProPress with copper, L copper on the hydronic side. This type of system, you can turn off the valves on the hydronic side, and you can move the indoor units where you want if another tenant comes in. So it's simple that way. That's pretty much.
Has it gotten easier as you've gotten a few different installs under your belt, or?
Yeah, I mean, the main thing is trying to keep the pipe level to the water pipe as much as you can. If you start jumping up and down, you got to put air bleeders because traps the air. Like if you got beams and stuff like that, you might have to go underneath the beam back up. Might trap air. You got to put some kind of air bleeder. The main thing is trying to keep the pipe level, a hydronic pipe.
The only thing I would add is during construction, it makes the management of the construction so much easier for the owner. I don't have to rely on someone walking the space looking for porta bands. I don't have to rely on someone making sure there's nitrogen in the tanks. It's water. I mean, it's pretty easy.
All right. So now we're on to, what was your experience installing the system versus a traditional system? So we'll start with Mike on this one, kind of similar to what you.
Yeah, I mean, they're pretty much similar. Just trying to think what would be different. Less refrigerant piping. Definitely less refrigerant. I think it's quicker to use the ProPress, the hydronic, run that hydronic piping and stuff like that. I think it's quicker than brazing and all that refrigerant piping and stuff. Definitely.
Tommy kind of shared his, a little less management on that last one. I guess Brad, from the design side, I mean, installation, how's this compare to some of the other VRF jobs you've done?
Well, I think the advantage is that it's very similar, right? So we throw the term hybrid in front of it, we throw water in the system, and we think this is completely different. It's something to learn. But many of the rules are the same. All the terminal equipment is the same. Really, the only difference is in the branch control box and the hydronic piping, from the branch controller to the fan coils. So Mike and Tommy mentioned one other thing. The the major difference from a planning and installation perspective is planning around the branch control box. It's larger. In addition to heat exchangers, you got a chilled and the hot water pump in there. There's drains that you need to account for. And one of the most important things you can do is, one, plan the location so that it's serviceable, so that you can get to drain. And two is make sure that you're specifying isolation valves on the downstream side of the branch control box, so that you don't need to drain down the entire system every time you need to move a terminal unit or move some pipe. That makes a world of difference in an office environment where you're expecting churn every couple of years.
I'd only add, as important as Boland is for the equipment, the installer is for water hydronic. Refrigerant goes anywhere you want it to go. Up, down, left, right, inside, outside, whatever. There's limitations, but it pretty much has high pressure and goes where you want to go. Water, we're running, and this is another big difference. We're at like 14 to 16 PSI. So I can cover it with my thumb. It's not big. And if you don't have a good installer and you have 590s in a 6-foot range, you're never going to get the air out. And water also expands and contracts differently. So refrigerant is refrigerant. Water, we've learned that when you heat, it expands a little further than it does. So it's really important to make sure you have a good installer. And part of the good installer is Jason and his team coming in the site and looking at it, making sure they're doing it as per the design. Jason's a Boland tech.
All right, so now a question that I think a lot of people here are going to be interested in. We're going to talk about cost. So Tommy mentioned some stuff, but how do the costs shake out on this project? What our equipment costs, the installation cost, and then the overall cost that Tommy sees as the owner. So I'm going to start with Mike, who can kind of give a budget of, with a hybrid VRF system, there is a little more accessories that might need to go into that system. We're designing around smaller sizes, right? So hybrid VRF can only go up to 14 tons. So what would you expect kind of as a equipment cost, the difference between traditional versus hybrid?
It's not new technology, but it is a closed loop hydronic system, which needs all the accessories that a hydronic closed loop system would need, right? Now we need expansion tanks. We want air separators. So like Mike mentioned, we need isolation valves so that we can service the equipment. And then we're adding components, right? We have heat exchangers and pumps that a traditional VRF wouldn't have. So just from the equipment point of view, we're probably looking at around a 10 to 15% increase in cost versus traditional VRF.
But you save on the install.
I was talking just equipment.
Again, just the equipment.
I'll let the experts talk about the install.
It is a little more expensive. With the new refrigerant change, we might see that gap get a little closer because there are a lot more sensors from a manufacturer standpoint we have to include. So we're still kind of waiting for that to shake out. But so we'll say 10 to 15% is kind of what Mitsubishi was expecting. Mike, how on the install side, are you seeing similar costs between refrigerant piping versus the water piping? Are you seeing a little cheaper? Is it, hey, the first one was a little challenging, but we're getting better?
Yeah, I don't know much about the cost. The bid team in my office.
How about the hours? The PM hours, are you seeing less or more with the field guys?
I would say it's probably about the same. Okay, maybe a hair more. All right, because I don't know. I mean, ProPresto is faster, but the material costs more. But I don't know the cost of stuff though.
Dancer again. You're seeing the hours are about the same, if not a little bit more. And then Tommy, kind of the final one. So right, we know what our cost is. The contractor sees what their cost is, but really what everyone cares about is what the owner is actually seeing all said and done. Kind of what's your experience with the first one, kind of lessons learned there. And then as we've now put in probably another 5 systems, are they getting cheaper? Is it about the same? Is it more expensive?
So when you work with a partner like GHT and we design it from the start, I think the cost, our first one was a 5% increase. And we actually had it closer than that if we used the plastic piping, but it was the lead time was longer. We couldn't necessarily get it. And we did a building, 1217th Street, with plastic piping, and we had all kinds of issues. I am ADD. I don't like to see the sag. So these saddles have to be 4 foot apart versus 8 foot apart. We ended up going with copper, and it ended up being 5%. I think when we design from the start and we look at the space holistically, I think we're within 5%. And the cost to run Again, this building was running as designed and as built in 1989 at an energy star score of 54. And that was not because we were running the building poorly, it's because that's how it was designed. How it's running now is we're at a 85, with all the new systems put in. And what that means for cost back to the owner is, in DC we have BEPS. It would have been a $7 million fine next year if we weren't compliant. Now, not only are we compliant, we're way over the threshold that has been set. So I think when you add the cost in altogether, I don't even consider traditional VRF an option anymore. I only look at hybrid VRF because there's no reason to go traditional VRF. I mean, again, everything that you look at, the systems work exactly the same. I don't think a person can tell you the difference. And we do have traditional VRF in this building on 2.5 floors before we changed over to hybrid. And now we have, I think, 7 completed and 3 under construction right now, with the 4th and 5th getting ready to start. No one would be able to tell you the difference. Absolutely not. And Mike said there was a little bit of noise. We had people sitting directly underneath branch selectors with no ceiling tile that would tell you they hear nothing. I sit in a room with a traditional VRF and I hear the fluid. The second floor over here, we have a sound studio that has a traditional VRF. And the branch selector, unfortunately, happened to sit right in the middle of the sound studio. And as it switches from gas to liquid, they hear the noise, and you can hear it on their noise. They hear the tss, and then the click noise. With the hydronic system, I have yet to hear it ever make noise, other than a lessons learned. We'll talk about that later. But
Brad, I guess we'll ask you as well, but cost, I'm assuming it's pretty comparable designing and designs, you know.
I wouldn't charge Tommy a cent difference between traditional and hybrid. Yeah.
All right. So now kind of we've gone through the install costs, things like that. Let's talk about lessons learned. So we'll kind of start across and go around. Brad, what are lessons learned engineering side? You know, as Tommy mentioned, we have a few under our belt, and you've seen some go good and some go bad. What have you kind of picked up on the design side for future projects?
I think the learning curve with hybrid VRF, again, going back to the branch control unit, which is sort of the heart of the hybrid VRF system. So we talked about it being a little bit bigger. Planning space for it might be a little more challenging. In addition to just the box, the accessories, an expansion tank, you need a domestic water makeup line for the hydronic portion. One of the things we learned specifically about the domestic water makeup line is that the code requires an ASHRAE 1012 or 1013 double check valve on any domestic water supply to prevent backflow into the potable water system. And that comes, the makeup kit comes standard from the factory, with these code compliant devices. The challenge there with an ASHRAE 1012 double check valve is that there's an emergency drain, and that needs to be piped to a drain.
Correctly.
And piped correctly, right. So, this isn't something that's going to dribble and leak. If that valve fails, there's going to be a lot of water coming out of here. So you need to pipe it and take it to a drain. That is a challenge. Fortunately, we had some brains on the project and, interpreting the code, and realized that you really only need one of those type of valves per system. So we installed one of those type of valves on the main supply to multiple branch selectors, and then used a 1024 ASHRAE double check valve, which does not require an emergency drain on the individual branch controllers. That eliminated several drains out in the office space that would otherwise have been required. And that took a little bit of coordination with Mike's team, because they provide this double check valve as a standard. So it was back and forth through the design and submittal process to make sure we got that right. What else? Lessons learned. That's a drain on the double check valve to the branch control unit. That branch control unit also has a condensate drain, a normal and emergency drain. As a design engineer, I try to go by gravity all day, every day. That's not always possible. You can use a condensate pump to remove condensate normally. However, these drains on the branch control unit are also the outlets after the flushing procedure during startup. And a little condensate pump with a 3/4 inch plastic hose isn't going to cut it. So you have to accommodate drainage for the branch control box.
All right, we're going to leapfrog to the other end. Mike, anything you saw? Lessons learned?
No, we installed condensate pumps on the branch selectors. But we also put a drain T, so when they come by to flush it, we can just throw it down there instead of going to the pump. That way, because the pump won't keep it up when they're flushing. Just keep the pipe level is the main thing, much as you can.
I'm seeing also just teaming up mechanical contractor and engineer on the same side and trying to fix that problem helps, right?
Yep. Mike was a big help. Yeah. So we were learning on that one together.
And Tommy, any lessons learned from supervising all of this and seeing them all get installed? Any changes from compared to your traditional VRF systems you have?
I'm going to go back and harp on what I said. The partners that you select and work with are 100% the biggest part of the success. From the equipment manufacturer to the sales team, to the installers, to the engineers. When you do it right, it's seamless. They didn't install one system, and it was the biggest nightmare we've ever had. Not from a manufacturing perspective, but from an install perspective. We got over it. I mean, going back to they didn't listen to what Brad said and piped the backflow preventers wrong and flooded space a couple times and couldn't figure out why we're doing things wrong, as well as had hundreds of 90s. But from an installation perspective and an operation perspective, every single solitary thing that was promised was delivered. And, we will continue to install nothing but.
Great. And then Mike, I know as the manufacturer, we should be, hey, our system's always fine and we know what we're doing. This was our first system in the area. And again, one of the first systems in the US. So any lessons learned kind of you've seen from our side?
Well, I would say that, as the manufacturer, on paper, my equipment works perfectly all day, every day on paper. But Tommy and Mike, they live in the real world, right? So our equipment does work great when it's designed well, when it's installed well, and when it's operated properly. And we try to do as much as we can as a manufacturer to help support all those different efforts, whether it's on the design side, to the installation side, to the operating side. And we put in a support networks in place so that whether it's Jason at Boland or some of the other people at Mitsubishi, so that as these situations arise, we can give the guys that live in the real world the support they need to make sure that they resolve those things and resolve it as quickly as possible.
To tag on that, I'm not sure if this is where I should talk about it, but were there some problems with a piece of equipment? Yes. We had one piece of equipment that the first one we put in had a pump that went bad 18 months in, maybe 20 months in. And, I got this cold shiver down my spine thinking, oh no, this is going to be the end of the world as we know it. The pump never stopped working. It worked. It just got loud. And then the client could hear it. The client actually didn't care. We looked at it and heard it and called it in and said, hey, we have a problem, right? And again, being scared, being the first and not knowing, it was like a 45-minute installation. The part was 2 days away. We actually had spare parts here. We put it in. The client never even knew that this issue happened. All the clearances that were asked for were given, and it was done. I mean, if that had been a VRF system, we just had a VRF system, a traditional VRF system, in another building that had a small leak. It was a $25,000 fix. I mean, and a 5-day process, because you have to drain it, you have to fix it, then you have to evacuate it and let it sit for 48 hours, and then you have to fill it. So no weekend I know of is 5 days long. So you're going with at least 2, if not 3 days of downtime for a client.
So I guess we'll springboard a little bit to that. So that's kind of the first maintenance issue you've had, but any other things that you've kind of learned? I know there was some, hey, topping off the water in there during different seasons. Any operational things that you do or different maintenance procedures that you've installed with your guys kind of to make sure everything is running?
Yes. We use water treatment, and we have our water treatment people check the loop on a monthly basis just to make sure it's right. Originally, again, I'm not saying I'm skeptical. I'm just saying I'd like to be proactive, not reactive. We had closed all our water valves. There's two types. You can either use a fill system or you can use a direct water hookup. We use direct water hookup. I wasn't confident that we wouldn't have leaks, so we turned the water off. We realized once you start heating water, it expands and some gets lost, and we had low water pressure. But that takes me to the second great thing is controls. The control that Metasys gives me as the building owner and my controls guys, which happens to be Boland, we use Tritium, give us the ability to see it And it's not like we're waiting for something to happen. We know what's going on. We can go fix it before the client ever sees it. So, I mean, and the integration with the controls is second to none. I have LG systems in other buildings. I have Samsung. I have Daikin. The control I get from the Medicine system is night and day better for me as the owner and me as the client, because we can see and control everything, and we can predictively say something's going wrong. We didn't wait for them to run out of water. Now we are confident. Now we have the water valves open all the time. We believe in our contractors. So it has been definitely a good thing.
Then you also put dye in your water, right? Yes. There is a leak. It's a little easier than finding refrigerant.
Yes, we prudently, our chief engineer decided, and we've done it portfolio wide, that we would dye our condenser water, and then we dye the water that goes in the system. So we can see, when we see you, I'm colorblind, but I think it's green and pink. So I think if you see green water, it's coming out of the condenser. If you see pink water, it's coming out of the hybrid VRF system. If you see clear water, you know where it is. If it's
That's a free tip. Doesn't matter if you're doing hybrid VRF or not. Dye your water system. Great. And so you kind of mentioned two controls. So this building is managed by Boland with the control system. It's a tritium front end, but we also do have Trane, and then that integrates seamlessly with the Mitsubishi control system. So, and that is exactly the same. So if you guys do have a building that has traditional VRF that's Mitsubishi, you can pull that system in, and then you can mix and match it with hybrid VRF. The controls doesn't know the difference between if you're running refrigerant or water. There'll be some different sensors, but overall, it's going to look the same to the front end.
And I mean, it is seamless. Like with said competitors, we turn on zones of VAVs or VRF cassette units. With the Trane system, with the Medicine system, we can turn on individual VAVs or cassette units. So when a client asks for 1 or 2 offices on for nighttime, we're not turning half a floor on. With all of the competitors, that is not the case. Or control, or the ability to see what it's really doing, or to control fan speed, or to control temperature at a fixed set. I mean, the controls is absolutely remarkable. And Matt back there from Boland, I'm telling you, the integration is the best ever.
Matt's our control guru in the back. He's also the sharpest one right now. Look at that. So that's kind of the general project and how the integration went. A few other things we want to touch on. So people have mentioned Jason Lawrence here. He also has now his sidekick, Michael, who's newest to the Boland team, but they are our DTS for the local area. So that's our Ductless Technical Specialist. It's a feature that Boland provides for free with all of our VRF systems that we sell. It's kind of a way for us to help ensure that a project's going smoothly. We've heard a lot about teamwork and making sure that the install matches what's on the paper and everything's installed how it should be. That's pretty much Jason's job, right? Let's make sure that we're not getting called back in a year or two if something doesn't go wrong. So I'd love to see just anyone here, if they want to chime in, their experience working with Jason, not to put him on the spot, but just kind of how you think that program's going, how it's worked out on your projects. Start off.
I would start by saying that Jason is a person and a product that no the competitors match or have. So you buy a traditional system from somebody else. Here's the system, put it in. I can't speak to any other market because we're not in any other market. That piece of the pie is so important, because when you catch something, just like you said, before it becomes an issue, a half a year or a year, or worse, during the installation, and shuts the job down or causes a delay in move-in, how do I put a value to that as an owner? Someone's supposed to move in March 1st. If something's wrong in the installation and we can't pass inspection or can't start it and can't move them in until April 1st, I lost 30 days of rent and can't save face with a client. They have come in from the start to service and have been able to absolutely 100% hit home runs every single solitary time. I mean, a brand new system, again, a pump goes bad, you think it's going to be the end of the world as we know it. 45 minutes, I was, up and operational. I don't know what to say. Most companies would say we have parts in the basement because we're prudent. We bought all these parts spare. Most manufacturer would have probably said, well, we'll wait for the one to come in 2 days. You guys, Jason and his guys, literally took out one we had spare in stock, put it in 45 minutes, was up and running. has caught plenty of things that these guys didn't do, but taught them how to do because it was new. I mean, he's got to be lifeline for you guys.
Yeah, anytime he started a new job, he'll come out, do a kickoff meeting, and he'll tell you the do's and don'ts and stuff like that, and make sure everything's in the right length.
Best practices.
And then, when you're done, you do another final measure of the piping, put it on the DSB, and send it to him. It makes sure everything's good. So it's been real good.
I mean, I know Mike and I work with Jason daily, if not, every 2 days, but essentially
Jason's so great.
yeah. He definitely, it's a good thing for us if we're not getting calls back about, hey, something went wrong in the field. Hopefully this means Brad's getting less calls. I don't know how often you've been on some calls with Jason, but hopefully it makes your life easier as well.
Jason was available when we were doing the first fit out, American Forest and Paper on the 10th floor here. We had a lot of questions, and so I was just going through my emails yesterday trying to recall that history, and Jason's name came up a lot. So,
And the best part about it is he always answers the phone. So when I call him, it's not like, oh shit, it's him again. It's he answers and answers any question I got, which again, I think that's a huge differentiator, and not just the equipment, but the company that supports the equipment.
All right. Well, again, appreciate everyone coming by. If you have any questions that weren't answered or anything that comes up, you can we're going to stay here for a little bit so we can come up and answer them. If not, reach out to your local Trane salesman. He should be able to get back to you. If you don't know who your local Trane salesman is, shame on them, but you can reach out to the local Boland email. Yeah.
That's a good one.
And then like Tommy mentioned, so we are going to be running tours periodically for the rest of the morning. So if you signed up for one, great. You should have your time slot. If you didn't sign up for one, I believe we still have slots. So feel free to stay by and we'll take you through some of the operational systems. You can see how it actually looks in real life. But without that, appreciate you guys coming in. Oh, and one last thing. If you are interested in just the general design of hybrid VRF, Mike Silverstein's going to be putting on a presentation at 11, same room here, going through more of the design specifics of it. So again, if you have some time, stay around for a tour, stay around for Mike's presentation. If not, again, we appreciate you guys taking the time today. I know you're all pretty busy people.